Yeah, hello, welcome. First, I'd like to mention that I'm here with my colleague and co-author, Norman Meuschke. So he's over there. I start with the outline. So the paper is about a new plagiarism detection system. And first I want to talk about the motivation, why we have developed this new approach. And then I will talk about the approach and how we try to identify plagiarism. And then I will talk about the algorithms we have developed to identify them. And I will give a short overview about our prototype. It's called CitePlag. And of course, if you build such a system, you want to evaluate it and show whether it's actually better than the existing systems. So that's what I will talk about that after that. And then I will give an outlook. So the currently available plagiarism systems, they have the problem that they are solely text-based. And Professor Dr. Weber-Wulff, she runs evaluations on the existing systems. And her conclusion is that plagiarism detection systems find copies, but not plagiarism. And the reason for that is that they compare the text of the documents and try to find identical patterns, so like n-grams, so words that follow in the same sequence and similar stuff. But if you paraphrase something or if you translate something, then the existing systems hardly find anything. And I mean, usually if a scientist plagiarizes something, then he will make a little bit of an effort and maybe try to change some words. So for that reason, it's very, very difficult to identify plagiarized documents. And of course, a human examiner, he will, if he's from the field, he might find it. But there are plenty of studies that have shown that even in databases like Archive and org and even in well-known journals, that the people that peer-reviewed the articles before the publication have not identified these plagiarized cases. Later we'll talk about a doctoral thesis of the former German defense minister, and he was caught. Some people already laughed, yeah. He stepped down, and but it took several years before people actually found out that his book, I mean, it wasn't just his thesis, but he even published it as a book. But still, it took a long time before he was identified as someone who plagiarized that. So now I'd like to give a brief overview about the existing systems. So in general, you can distinguish these available systems into a local similarity assessment and a global similarity assessment. You can see that here. So the left branch talks about the local similarity assessment and the right one about the global. As I said, the main...
Sorry, can you come back to the microphone?
Sorry? Oh, sorry, yeah, of course, for the for the recording. So the existing systems are based on text comparison, on string comparison, and on keyword analysis. For example, one way these similarities are calculated is just by performing a statistic analysis of frequencies and occurrences of certain keywords. Or another very popular method is to create fingerprints on documents. And another method that is used, but the performance is not the best, is to analyze the use of certain words and grammatical constructs, punctuation and so on, so that you can identify whether the style is consistent within one document or whether maybe different people have worked on that. Although this is not really helpful to identify plagiarism for in the context of scientific articles. I'd like to talk about fingerprinting a little bit more because that's the most commonly used technique. So you see on the right side, I hope that the font size is large enough. You see an example, and this is a sentence. So you can create a fingerprint from this sentence, and then you store or create a hash value, store it in a database, and then you just compare these hash values in a large database. And this way you can see whether maybe a sentence or a paragraph has been used before somewhere else. And if you find a collusion, So if you find two identical sentences in such a hash table in a bucket, then it might be worth to look a bit closer and to see whether this is a identical sentence or paragraph. But this shows again the problem that if you create such a fingerprint, even if you just alter a single word, then the hash value would be completely different and you wouldn't recognize a sentence as maybe that it has been used in another source before. Now I'd like to talk about the new approach we want to present. We call it citation-based plagiarism detection. It might sound strange in the beginning, because usually if you plagiarize something, then you think that maybe you don't really use citations. But we have observed that if people plagiarize, they use citations, because if you want to publish something, you need citations. And usually people paraphrase their work, but they use a lot of the citations that also have been in the original work and maybe alter them a little bit. So in this figure, you can see that in document A, there's a citation on document C, D, and E. And in document B, there are also references or citations to document C, D, and E. And they are in a very similar order. In document B, there are two additional citations, but otherwise it's pretty similar. So if you just compare the order of citations, you recognize a pattern. And the idea of citation-based plagiarism detection is to look for these patterns in scientific documents and to check them for, whether there might be something wrong, maybe there's something plagiarized. So the suitability for plagiarism detection depends on certain characteristics. For example, the order of citations or the textual proximity of citations, whether citations are in the same paragraph or maybe even the same sentence. Another factor we take into account is the probability of co-occurrence. For example, if there are two papers and both papers are very popular and have been cited thousands of times, of course it's more likely that they are co-cited in other documents as well, as if two documents that have hardly been cited, that they are co-cited. Another factor that we consider is the citation style. So depending on the citation style, the order of citations can alter. So you can have citation 5, 3, and 4 in one bracket, or you can just have 3 to 5. So in this case, citation 5 and 4 would not be right next to each other. Or very often in scientific documents, you have tables that contain multiple citations, maybe even taken over from another source. And then we have some challenges in order to identify them. So we have transpositions, so that the order of citations changes, or scaling, so that maybe some other citations are in between the citations, or that the whole alignment is completely different, so that maybe in document A, a part or a whole paragraph from the conclusion is used in another document in the introduction and so on, so that it's just mixed. In order to identify these patterns, we have developed some algorithms. They're called longest common citation sequence, greedy citation tiling, and citation chunking. Bibliographic coupling is an approach that has already been used, not for the purpose of plagiarism detection, but for citation analysis purposes. In this table, they distinguish whether they look for global similarity or local similarity, and whether the order is preserved or not preserved. And now we'll talk a little bit about these algorithms. So on the left, we see bibliographic coupling. And bibliographic coupling just describes or measures the amount of shared citations between two documents. So in this case, we see that document A and document B, that they both cite document C and D. So the coupling strength would be 2. In our analysis with database with PubMed, we have found documents that share more than 20 citations. But of course, this alone doesn't indicate or show even prove that this might be plagiarized. It's quite normal that if you have publications from a certain field, that they share references. On the right, there's a description of the longest common citation sequence. So this just examines whether, if there are two documents, whether they share citations in the same order. So all the red numbers are citations, and the red numbers are the citations that are shared by both documents. And in this case, 3, 4, and 5 would be the longest sequence. Then we have the algorithm Greedy Citation Tiling, and Greedy Citation Tiling aims to identify all matching substrings. And I think it's pretty easy to understand, so I won't talk too much about it. A bit more complex is citation chunking. With citation chunking, we don't have a fixed length for the citation string we analyze, but the size of the string depends on the citations that occur before the substring of citations or after. And if there are similarities, then there will be included in the citation chunk. And this way, we have an algorithm that works quite well for local similarity, not so much to compare similarities between two documents in general, but on a very local basis, for example, within one paragraph or one section. I think the time is not enough that I will talk about the algorithm in detail, but maybe if there's some questions later, I will come back to that. So if you develop a new plagiarism detection system, it's very difficult to evaluate that, because if you use an artificially created test set, then it might not be really realistic, because if you try to disguise plagiarism, then there are very different methods. You can, in the simplest form, is just that you copy and paste, or that you maybe paraphrase everything a little bit, or that you paraphrase it a lot. So by creating an artificial test set, the results might not be that realistic. Another possibility would be to use actually plagiarized documents, but there you have the problem that you usually don't know where is the plagiarism in this document. You don't have the ground truth. You don't know how many sections were plagiarized and what were the sources. And if you use available systems, then you only find what you can find with available systems anyway, so you will not find more than that. And obviously, it would be best to have a real document, a real-world example that is not artificially created, but it should also be well examined, so that you really know as many parts of the document that have been plagiarized. So I will talk a little bit about our evaluation of a real plagiarism case of the former German defense minister, Mr. Guttenberg. This was his doctoral thesis, I think around 350 or 400 pages. And I will talk briefly about our evaluation of the PubMed database. We use the open access part of that. And here you see a little summary of the different test collections that we considered using, and you see the advantages and disadvantages. The PAN corpus is an artificial created corpus, which we would have loved to use, because it was created for a conference to measure the performance of different plagiarism detection tools. So it sounds perfect. The only problem is that all existing systems only analyze the text of documents. So in this artificially created corpus, no citation information is available. That's why we couldn't use it. So now I come to the thesis of Mr. Guttenberg. What you can see on the left is the thesis with all the pages, and all the colored parts show plagiarized parts. So you see it's a lot in there, and from different sources. And this graph, this figure, was derived from the findings of the Guttenberg project. It was a crowdsourcing project where hundreds of volunteers tried to find as many, all the pieces that have been stolen. So we believe that it's quite comprehensive and includes probably not all the plagiarized parts, but at least it should be a very good data set to evaluate different algorithms. What you see on the right is a figure that shows how long it took to identify all these different various plagiarized sections. And what is quite obvious that in the beginning it might be quite easy to find the plagiarized section, but it gets harder and harder. The first 5% of plagiarism is pretty easy. You just need to digitize, maybe make an, in this case it was only a book available, but you can make OCR and then you use the existing systems and then you might find around 5%. That's what we found with a software tool called Ephorus, which is supposed to be one of the best packages. So with this commercial tool we found 5% of the translated plagiarism, I have to say, or even less than 5% of the translated plagiarism. Overall, 63% of the lines in this document are plagiarized and 94% of the pages contain plagiarism. This slide shows on the left the original source of a document, and underneath you see Guttenberg, so that's the doctoral thesis. And same colors symbolize same sources or same citations. And for this evaluation, we used the 16 sections in this thesis that have been identified as plagiarized, but they were all translated from other sources. So it's not just German or English, but translated from, for example, from English to German. And the existing tools couldn't identify any of these translated sections. So we wanted to know how well would the citation-based approach work to identify these sections. And as you see, even with applying any algorithms, you see that there are certain patterns you can recognize. So the big graph on the bottom on the right, you see, so there are only 2 pages, but they contain, I don't know how many citations there were, maybe 15, something like that. And you see that there are some similarities. If you apply these algorithms I just presented, and if you clean this up, the whole sequence of citations, then the result is this, what you see at the very bottom on the right. And you see that the order of citations is quite similar. And that's not a coincidence, obviously. So if you use these algorithms and see that there are more than 3 or 4 citations in the same order, that might be a strong hint that a section has been plagiarized. The table above shows some figures. So the copy and paste plagiarism that was identified in the thesis. If you use the existing software, you have pretty good results. So you find like 70% or more of the copy and paste plagiarism sections. And the citation-based approach is not suitable to identify copy and paste plagiarism, because obviously if a section is very short, it only contains maybe 1 or 2 or maybe not even a single citation, so it doesn't deliver very good results. For the sections of disguised plagiarism, the tools identify less than 10%, so it depends how strong it is disguised. And in our case, it was around 30%. Then idea plagiarism is, of course, very, very hard to find, because if you compare text, you might not find any words that are similar, or if you find them, then maybe there are 100 words in between. So the existing systems are not really suitable to identify idea plagiarism. With citation-based, you can find them sometimes. It really depends on the way how someone plagiarized. And even for a human examiner, it's very hard to identify idea plagiarism, just the nature of it. But where the citation-based approach delivered pretty good results was with the translated plagiarism. So in these 16 examples, you see that some of them, for example, on page 224, there were only 2 citations. So you wouldn't be able to identify such a section as plagiarized if you use a citation approach. Because if you would look at all these sections, you would just have way too many false positives. But if you put the threshold maybe on 3 or 4 citations in the same order, then you get pretty useful results. Are there any questions to this figure? Okay. This graph shows the results when we ran the analysis on PubMed. I won't go too much into detail. I just want to show some figures. So what you see here is on the left, it's not a logarithmic scale, but on the right it is. So you see that on the y-axis you see the document pairs amount, and then on the x-axis you see the coupling strengths. I talked about this. So the amount of shared references between 2 documents, and you see, for example, that that if you look for a coupling strength of 8, that you still find quite a lot of documents. So this alone is not really useful to identify plagiarism, because you would just have way too many false positives. And that's why it's important to combine it with all the other algorithms where you consider the order of citations and patterns and so on. The strengths and weaknesses of the algorithms are displayed in this table. So what you see is that the citation chunking algorithm delivers pretty good results for most cases and most forms of plagiarism. And the longest, greedy citation tiling has some advantages in some cases, and the same is true for the longest common citation sequence. In the following, I'd like to talk about our software system that we have developed to identify this plagiarism and the steps that are involved. So in the first step, we just convert the PDF document to an XML document and identify the citations. We use an open source software for that called Paraphrased, with some minor modifications. For example, in our case, it's important that we know where and which sentences the citation is and where exactly it stands. So we're not just interested in extracting the bibliography of a document, but we want to know where in the full text the corresponding citations are located. And then we match them with our database. We do some article deduplication and author name disambiguation. Then we run the citation-based plagiarism detection tools, algorithms, and compare the entries in the database, see whether we find any matching entries. And then we generate a report using the citation-based approach. And we also use text-based plagiarism detection software, because, as I said, for example, short sentences and so on, they can be better detected with text-based approaches. Yes, and then in the very end, they're combined, and you get the results. So I think my time is nearly over. So to conclude, the existing systems, they deliver a pretty good job for copy and paste plagiarism, but they struggle to identify plagiarism that has been disguised, or like if it has been paraphrased, translated, or idea plagiarism. And we see the strengths of the citation-based approach in cases where the document has been altered a lot, like in translations or strong paraphrasing. The citation-based approach should not be seen as a substitute, but rather an extension of the existing approaches. And yes, the results, at least we were pretty happy with them. And we hope to implement that on a larger scale and establish a larger database with citation information and see where we can apply it in the future. There's also maybe talk about the outlook a little bit. Something else we want to include is a consideration of the argumentative structure, so that we analyze keywords. For example, if it said Hamilton argued something and whereas someone else said something else, that you include these words and that you compare not just the pattern of citations, but also how these citations stand to each other and what kind of context. And last but not least, we don't only want to look for plagiarism, because in many cases it can be interesting to see if you read a paper, what other papers have been read by the author that have not been cited. So that does not mean that it's plagiarism. But with putting the threshold a bit lower, you can identify documents that have been read, and maybe, for example, some sources from this document have been used for his own work. And so it can give you maybe some ideas for further reading that might be interesting, and this reading was at least of interest for the author. Yes, that's it. Thank you. Any questions?
Okay, we're running a little bit behind time, but we have time for one, possibly two quick questions. Okay, I'm going to ask a question. What's the performance of your algorithm like? How long did it take you to do the analysis?
Yeah, so at the moment, for example, on PubMed with several 100,000 articles, depending on the algorithm, they have different running times, but around a week. But if you have computed these times, then obviously it's way faster. If you just have a new document, then it's a matter of a few seconds. Yeah.
Curious if you thought about what adaptations it would take to use this not so much in the plagiarism case, but in the self-citation case, where you're trying to determine how much is new in the paper.
Yeah.
Could you repeat the question?
So, if I understood the question correctly, the question is how can you, whether you could use this technique to identify what's worth reading in a paper you got, or whether it's just something that has been published before, maybe even by the same author. Yeah, so I think that is really a good question, because if you use this technique, you could, for example, highlight the parts of documents that are really new. So you would save a lot of time for the reader, and he could focus on what's really relevant and what's worth reading, and not just reading all the related work before that you have read maybe somewhere else before. So you can use it for recommendation systems. That's definitely a good way to use it.
Okay.
Okay.
Thank you very much.
Thank you.